Sam stared at the broken ruler, thinking there had to be a better way to measure things. At the market, Sam noticed the tilted scale and couldn't help but imagine a better design. Back home, the overflowing water gave Sam another idea for a simple yet effective solution.
Have you ever wondered how we know how tall we are, or how much flour to put in a cake, or how much milk to pour into a glass? Measurement is a fundamental skill that we use every single day, often without even thinking about it. It's how we understand the world precisely and consistently. It helps us describe objects and quantities with numbers. From cooking to building, measurement is the secret ingredient. It's a universal language everyone can understand. Imagine baking a cake with no measuring cups or spoons. You'd have to guess the flour, the sugar, the butter. The final cake might be a masterpiece or a sticky flat disaster. Measurement provides rules and tools to get the same outcome every time. It takes the guesswork out of important tasks. It lets us be accurate and reliable in the kitchen, in the workshop, and in a science lab. Measurement is the foundation of consistency and predictability. This guide is about mastering three common types: length, mass, volume. Length tells us how long or tall something is. Mass tells us how much stuff is in an object, often thought of as weight. Volume tells us how much space something takes up. By the end, you'll understand these clearly. We'll explore them one by one with simple, real-world examples from home. Our goal: make you a measurement master in minutes. Think about where measurements show up in your life. Measuring how far you can kick a ball. Lifting a heavy backpack full of books, filling up a water bottle before you go. Measuring isn't just for scientists, it's a practical life skill for everyone. It helps us make informed choices, follow instructions, and communicate clearly. This guide will give you the confidence to measure anything with ease and precision. Using a ruler is easy, once you know the basic steps. Let's practice by measuring the length of a common object, like a book. First, get your ruler and the book you want to measure. Place the book on a flat surface like a desk or a table. This is important because if the book is at an angle, your measurement might not be accurate. A steady flat surface ensures you are measuring the true length. Next, take your ruler and look at the markings. You will see numbers and lots of small lines. These lines represent the units, like centimeters and millimeters. Make sure you know which side of the ruler you should be using. Now, let's take the measurement. Place the ruler alongside the edge of the book you want to measure. The most important step is to align the 0 mark on the ruler with one end of the book. Some rulers start their measurement right at the physical end of the ruler, while others have a line marked 0. If you just line up the end of the ruler, you might be adding an extra unmarked bit which would make it incorrect. Always check for the 0 mark and start there. With the 0 mark aligned, look at the other end of the book. See where the edge of the book lines up with the markings on the ruler. Read the number on the ruler that is closest to the end of the book. For example, you might see that the book ends just past the number 21. This means the book is more than 21 centimeters long. Now, look at the smaller lines between the numbers. These are usually millimeters. Count how many small lines there are past the 21. If the book's edge lands on the 5th small line after 21, then the length is 21.5 centimeters. Sometimes, the edge of the object won't line up perfectly with a mark. It might fall between two of the smallest lines. In this case, you have to estimate. Look closely and decide which mark it is closer to. This is a normal part of measuring. It is also very important to keep your eye directly above the mark on the ruler. If you look at it from an angle, the reading can appear to shift, which is an error called parallax. Always look straight down at the ruler to get the most accurate reading possible. Finally, write down your measurement and don't forget to include the units. 21.5 is just a number, but 21.5 centimeters is a measurement. Section 3. Using a tape measure for bigger things. When you need to measure something larger than a book, a ruler just won't do. This is where a tape measure comes in handy. A tape measure is perfect for measuring furniture, windows, the dimensions of a whole room. Let's try measuring the width of a table. First, get your tape measure. Most common tape measures have a metal hook at the end. This hook is a very useful feature. You can hook it onto the edge of the object you are measuring. This holds the tape measure in place, so you don't need a second person to help you. It also ensures you are starting your measurement right from the very edge. To measure the width of your table, hook the end of the tape measure onto one side. Then, walk to the other side of the table, letting the tape unwind as you go. Pull the tape straight and tight across the surface of the table. It is very important that the tape does not sag or bend. A sagging tape will measure a longer distance than the actual flat width of the table, leading to an incorrect measurement. Keep the tape as straight and parallel to the edge as you can. A straight line is the shortest distance between 2 points, and that is what we want to measure here. Once the tape is straight and tight, look at the number where the tape meets the other edge of the table. Just like with a ruler, you will see numbers for larger units and smaller marks for smaller units. Tape measures often have markings for both centimeters and inches, so make sure you are reading the correct scale. Read the measurement to the nearest millimeter if you can. For example, the edge of the table might land on the mark that indicates 85.3 centimeters. Your tape measure might also have a locking mechanism. This is a button you can slide to hold the tape in place, so it doesn't retract while you're trying to read it. After you've read the number, you can release the lock and let the tape measure carefully retract back into its case. Be careful, as some tape measures can snap back very quickly. Always write down your measurement immediately so you don't forget it. Remember to include the units, such as cm or m. Using a tape measure is a great skill for many do-it-yourself projects around the house. Buying a new rug, rearranging furniture, hanging a picture frame. It is a tool of planning and precision. Section 4. Converting units and practice problems. Sometimes, you will measure something in one unit, but you will need to express it in another. For example, you might measure a table in centimeters, but the store lists sizes in meters. This is why knowing how to convert between units is so important. Converting metric units is easy. They're based on 10. Relationship between common length units: 1 centimeter, Salisbury 10 millimeters, 1 meter, Salisbury 100 centimeters. These simple facts are all you need. Example time. Imagine you measured a ribbon. It is 250 centimeters long. How many meters is that? 100 centimeter trimeter, 1 m. So count groups of 100 and 250. We do this by dividing. 250 centimeter, 100 taber 2.5 m. The ribbon is 2.5 meters long. Now the other way. A piece of wood is 1.5 meters long. Find the length in centimeters. 1 mem 1 stirs 100 centimeters. So we multiply. 1.5 met x 100, 150 centimeters. It's that simple. Centimeters to meters, divide. Meters to centimeters, multiply. Your turn to practice. Read each problem and try to solve it. Check your answer below. Mistakes are fine. Focus on the process. Practice. Problem 1. Smartphone is 162 millimeters long. How many centimeters? Practice problem 2. Doorway is 2.1 meters tall. You need the height in centimeters to check bookshelf fit. What is the height in centimeters? Answers. Answer 1. We want to convert mm to cm. 162, 10, m 16.2 centimeters. Smartphone, Behringer 16.2 centimeters. Answer 2. We need to convert m to cm. 2.1 x 100 Behringer's 210 centimeters. Doorway, Behringer 210 centimeters. Keep practicing with objects around you, and soon these conversions will become second nature. Section 1. What is mass? Units and tools. Now that we have mastered length, let's move on to our next big concept, mass. So, what is mass? Mass is the measure of how much stuff or matter is inside an object. Everything around you, from a tiny feather to a giant boulder, has mass. It is a fundamental property of all physical objects. We often use the word weight in everyday life, like when we weigh ourselves on a bathroom scale. While they are technically different in science, weight is the force of gravity on an object's mass. For our everyday purposes on Earth, we can think of them as the same. When we measure mass, we are essentially asking, how heavy is this? Just like with length, we need specific units to talk about mass. The most common units you will encounter are the gram, g, and the kilogram, kg. A gram is very light. A single paperclip has a mass of about 1 gram. We use grams to measure small, lightweight things, like spices for a recipe, or the mass of a strawberry. For heavier items, we use the kilogram. 1 kilogram is equal to 1,000 grams. A standard bag of sugar or flour from the grocery store often has a mass of 1 kilogram. You would use kilograms to measure your own body mass, a bag of potatoes, or a heavy suitcase before a flight. To measure mass, we need the right tools. You have probably seen several types of scales before. Kitchen scale, bathroom scale, triple beam, balance, simple balance scale. A balance scale works by comparing the mass of an unknown object to the mass of known objects. It is like a seesaw. When both sides are perfectly balanced, you know the masses on each side are equal. For our purposes, we will focus on the scales you are most likely to use at home, the digital kitchen scale. These modern scales are incredibly precise and simple to operate. They remove the guesswork from measuring and allow for very accurate results, which is especially important in activities like baking, where the right amount of each ingredient is crucial for success. Choosing the right scale for the job matters. You wouldn't try to measure a pinch of salt on a bathroom scale, and you wouldn't weigh yourself on a kitchen scale. Each tool is designed for a specific range of masses. Section 2. Using a kitchen scale. Step by step. Using a digital kitchen scale is a straightforward process. It gives very accurate measurements. Let's walk through it by measuring the mass of an apple. First, find a flat surface. Make sure the placement is stable. And check that it's level. Like a kitchen counter. If the scale is tilted, it might not give you an accurate reading. Turn the scale on. Press the power button. The digital display will light up. It will usually show 0, 0.0. Wait for it to show 0 before you place anything on it. Before you put your apple on the scale, you might want to place it in a bowl. This prevents it from rolling off. We don't want to include the mass of the bowl. This is where the tare or 0 button comes in. Place the empty bowl on the scale first. The display will show the mass of the bowl. Now press the tare button. The scale resets to 0 even with the bowl on the scale. The scale has now subtracted the mass of the bowl. It's ready to measure only what you add next. With the scale showing 0, gently place the apple inside the bowl. Be careful not to press down on the bowl or the scale with your hands. Let the scale settle for a moment. The numbers might fluctuate for a second before stopping. This final number is the mass of your apple. For example, the display might read 152 grams. This means your apple has a mass of 152 grams. It is that simple. Once you have your measurement, you can remove the apple and the bowl. Remember to write down your measurement right away, including the units. Is it 152 grams? Or 152 kilograms? The unit is essential. Most kitchen scales allow you to switch units. Grams, ounces, milliliters for liquids. Make sure your scale is set to the unit you want, usually grams. When you are finished, press the power button to turn the scale off. Many scales also turn off automatically after a minute or two of inactivity. Section 3. Precision and common errors. When we measure, we want to be as accurate as possible. Digital kitchen scales are great, very precise, often to the nearest gram. A scale that measures to 0.1 grams is more precise than one that measures to 1 gram. For most cooking, measuring to the nearest gram is fine, but watch for common errors. One big mistake, forgetting to use tare. If you place an apple in a bowl and put the bowl on the scale without tearing, the scale shows apple plus bowl. That gives a number much higher than the apple's actual mass. Correct versus incorrect measurement. Always follow this two-step habit. First, place the empty container on the scale. Second, press tare to reset to 0. Then add the item you want to measure. Another source of error, an unlevel or wobbly surface. Digital scales use load cells to measure force. Uneven surfaces distort readings. Put the scale on a solid, flat countertop. Low battery can affect accuracy. Look for fluctuating or dim readings. Replace batteries and keep equipment in good working order. Don't lean on the counter or scale while measuring. Even slight pressure alters the reading. Also, watch drafts from open windows. Gusts can affect very light items. Recap: use tare, ensure level surface, check batteries, and avoid interference for reliable measurements. Section 4. Converting units and practice time. Just as we did with length, we sometimes need to convert between units of mass. The main conversion you will need is between grams and kilograms. The relationship is very simple. It is based on the number 1,000. Remember this key fact: 1 kilogram equals 1,000 grams. This is all you need to know to switch between these two units. Example: recipe calls for 1.5 kilograms of flour, but your scale only measures in grams. Example: you buy 500 grams of coffee and want to know what fraction of a kilogram that is. The conversion rule is the same as with length. To convert from a larger unit to a smaller unit, kilograms to grams, you multiply. Since there are 1,000 grams in 1 kilogram, you multiply by 1,000. For example, convert a 2.5 kilogram bag of rice into grams. We calculate 2.5 kilograms multiplied by 1,000 equals 2,500 grams. So, the bag of rice has a mass of 2,500 grams. To convert from a smaller unit to a larger unit, grams to kilograms, you do the opposite. You divide. Say you measured 750 grams of strawberries. To find the mass in kilograms, 750 grams divided by 1,000 equals 0.75 kilograms. Now it is your turn to put this knowledge into practice. Solving a problem yourself is the best way to learn. Take your time, think about the rule, then check your answer below. Don't be afraid to get it wrong. Every attempt helps you learn. Practice problem. The recipe calls for 1.2 kilograms of potatoes. Your digital kitchen scale shows 1,350 grams. Do you have enough potatoes? First, convert 1,350 grams to kilograms. Here is the solution. Answer. Convert 1,350 grams into kilograms. Since we're going from smaller to larger, divide by 1,000. 1,350 grams divided by 1,000 equals 1.35 kilograms. The recipe calls for 1.2 kilograms. You have 1.35 kilograms. Since 1.35 is greater than 1.2, you have more than enough potatoes. Great job. Keep practicing and soon you'll convert between grams and kilograms in your head. We have explored how long things are with length and how heavy they are with mass, and now, let's dive into our final measurement concept, volume. Volume is the measure of how much space an object or substance takes up. Everything around you has volume. The air in a balloon, the milk in your cereal bowl, the book you are reading. It answers the question, how much room does it fill? For a box, volume equals length times width times height. For a liquid, it's how much of a container it fills. Understanding volume is essential for cooking and for filling up a swimming pool. To describe volume, we use specific units, just like for length and mass. The most common units for liquid volume are the milliliter, written as mel, and the liter. A milliliter is a very small amount of liquid. About 20 drops of water make up 1 milliliter. Diagram, visual scale, a single drop next to a teaspoon, about 5 milliliter, and a 1 liter carton of milk. We use milliliters for small quantities like medicine doses or flavor extracts for baking. The liter is a much larger unit, made up of 1,000 milliliters. You often buy drinks like milk, juice, or soda in 1 liter or 2 liter bottles. You would use liters to measure the amount of water in a fish tank or the amount of gasoline in a car. When we measure the volume of a solid object, we sometimes use a different unit called the cubic centimeter. Imagine a tiny cube where each side is exactly 1 centimeter long. The space that little cube takes up is 1 cubic centimeter. A fun fact is that 1 cubic centimeter is exactly the same amount of space as 1 milliliter. So, 1 cubic centimeter is equal to 1 milliliter. To measure volume, especially for liquids, we use special tools with measurement markings on them. In the kitchen, the most common tool is a measuring cup, or a larger measuring jug. These are designed to make it easy to pour and measure liquids like water, milk, or oil. They have lines on the side that show different amounts, usually in milliliters or cups. For more precise scientific work, you might use a graduated cylinder. This is a tall, thin tube with very accurate markings on the side. It allows for more precise volume measurements than a wide measuring cup, because a small change in volume creates a larger change in the liquid's height. Measuring the volume of a liquid like water or juice is a common task, especially in the kitchen. Let's learn how to do it accurately, using a standard measuring cup or jug. Place the measuring cup on a flat, level surface. Do not hold the cup while you pour. Holding it can tilt the cup and cause errors. A level surface makes the liquid horizontal for an accurate reading. Pour slowly into the cup while watching the side. Stop when near the desired line. Example, 250 milliliters out. Pour until near the 250 milliliter mark. Pour very slowly as you approach the mark. If you go over, tip a little out until it's right. Steady hands give exact amounts. Now, get down to eye level. The liquid surface curves slightly. The ba men ne iskas. Read from the bottom of the curve. Looking down makes it seem lower. Looking up makes it seem higher. Eye level removes parallax error. See which line the bottom touches, and that's the volume. If it aligns with 250 milliliters, you have 250 milliliters. Write down your measurement. Don't forget the units. Milliliters. Use a flat surface. Pour slowly. Read at eye level. This process guarantees accurate measurements for recipes and experiments. It turns a guess into a precise action. Measuring the volume of a liquid is straightforward, but what about a solid object that isn't a simple cube or sphere? How would you find the volume of a small stone? How about a key, or a toy car? You can't just measure its sides easily. For this, we can use a clever trick discovered by an ancient Greek scientist, Archimedes. This technique is called the water displacement method. The big idea: place an object into water and it pushes some of the water out of the way, or displaces it. The volume of the water pushed aside equals the volume of the object. You'll need a measuring cup, a graduated cylinder, and an irregular object, like a small stone. First, fill the measuring cup with enough water so the stone will be completely covered. Make sure the stone can be fully submerged. Place the cup on a level surface and read the starting volume. Get down to eye level and read the bottom of the meniscus. Let's say the starting volume is 200 milliliters. Write this number down. It's your initial measurement. Now carefully place the stone into the water. Don't drop it in. That could splash and ruin the measurement. Instead, gently tilt the cup and let the stone slide down the side. Once fully submerged and resting on the bottom, the water level will rise. That's because the stone now takes up space the water used to occupy. The water had to move up to make room. This new, higher level is our second measurement. Look again at eye level. Suppose the new volume reads 230 milliliters. Now do a little subtraction. Final volume minus starting volume gives the stone's volume. 230 minus 200 equals 30 milliliters. The stone's volume is 30 milliliters. 1 milliliter equals 1 cubic centimeter. So that's 30 cubic centimeters. This simple method works for almost any small, waterproof object, no matter how strange its shape. Just like with length and mass, you will sometimes need to convert between different units of volume. The most common conversion you will encounter is between milliliters and liters. The relationship between these two units is simple, and based on the number 1000, which is a common theme in the metric system. You just need to remember this one fact: 1 liter equals 1000 milliliters. This simple rule is all you need to switch back and forth between these units, which is useful when a recipe asks for 0.5 liters of stock, but your measuring jug is marked in milliliters. The process for converting is the same one we have used before. To convert from a larger unit to a smaller unit, liters to milliliters, you multiply by 1000. For example, if you have a 2-liter bottle of soda, how many milliliters is that? You would calculate 2 liters times 1000 equals 2000 milliliters. So, the bottle contains 2000 milliliters. To convert from a smaller unit to a larger unit, milliliters to liters, you do the opposite and divide by 1000. For instance, if you measure 750 milliliters of juice, you can find the volume in liters by calculating. 750 milliliters divided by 1000 equals 0.75 liters. Now it is time to test your skills with a practice problem. Thinking through the problem on your own is the best way to solidify your understanding. Take a moment to read the problem. Decide whether to multiply or divide, and then perform the calculation. You can check your answer below. Don't worry about making mistakes. The goal is to practice the thinking process. Practice problem. You use the water displacement method to find the volume of a small toy. The water started at 150 milliliters and rose to 185 milliliters. What is the volume of the toy in milliliters? And what is its volume in cubic centimeters? Here is the solution to the problem. Let's see how you did on your final practice question. Answer. First, we find the volume in milliliters by subtracting the starting volume from the final volume. The calculation is 185 milliliters minus 150 milliliters equals 35 milliliters. So, the volume of the toy is 35 milliliters. For the second part of the question, we need to convert this to cubic centimeters. We learned that 1 milliliter is exactly equal to 1 cubic centimeter. This means there is no calculation needed. The volume of the toy is also 35 cubic centimeters. Congratulations, you have now learned the basics of measuring length, mass, and volume. Congratulations, you have made it to the end of our measurement adventure. We have covered a lot of ground in a short amount of time. You have learned about the 3 fundamental types of measurement that we use every day: length, mass, volume. We explored how length tells us how long something is. Units like centimeters and meters. Tools like rulers and tape measures. Mass tells us how much stuff is in an object, measured in grams and kilograms, using precise digital scales. Volume is the space an object takes up, measured in milliliters and liters. With measuring cups, you now have a solid foundation in the language of measurement. Throughout our journey, a few key principles apply to all types of measurement. Use the right tool for the job. Tape measure for a room, kitchen scale for flour, measuring cup for milk. Follow clear, step-by-step procedures to be accurate and reliable. Start at the 0 mark on a ruler. Use the tare function on a scale. Read the meniscus at eye level. These details separate a wild guess from a precise measurement. They are the habits of a true measurement master. We also unlock the power of unit conversions. Switch between millimeters, centimeters, and meters, between grams and kilograms, between milliliters and liters. The metric system makes this simple, based on tens, hundreds, thousands. This skill helps you compare sizes, follow recipes, and make sense of the world. Measurement isn't just for class, baking cakes, rearranging furniture, checking luggage weight, and so much more. It's a skill for life. Plan, create, communicate with confidence. To finish, here's a quick checklist to keep in your mind whenever you need to measure something. First, always choose the right tool for the task. Second, take your time and read the measurement carefully. Avoid parallax. Third, make a quick estimate first to check your answer. Finally, always write down your units. With these tips and knowledge, you are ready to go out and measure your world. Keep practicing with objects around your home. The more you measure, the more natural it will become. You are now officially a measurement master.